heard about us. We're an abstraction layer for Kubernetes that aims to make Kubernetes and Docker radically simple. With me here is Adolfo, SE manager. He's going to take a risk and do a live demo.
So Neil's very skeptical about live demos.
I have this thing for live demos. If they all backfire,
it's a gamble.
It's a gamble. Yeah. So I'm going to talk for a little bit. I'll try and keep it short to leave as much time for Adolfo to do the demo, but feel free to interject and ask questions. So anyone that creates applications knows that containers, and by virtue Kubernetes, is the way that you ship applications. It's the way now. It's the given. It's the only logical way. Hold the mic.
Yeah. Don't just drop it at the end. You just go.
Is that better? Is that better? I always think that I'm a loud person and everyone can hear me naturally. But the edge is a different beast. And if you think about Kubernetes being quite complicated, edge and Kubernetes together, you'd think would actually elevate complexity quite dramatically. But there's a number of really good reasons why Kubernetes at the edge just makes sense. I'm going to go through these. So if you think back how you used to ship applications, it was always with installers. You had MSI installers or other types of installers, and they were a nightmare. You were always fighting with library mismatches, version conflicts, all this stuff. It was an absolute nightmare. And one of the major benefits with Kubernetes is that really we have a recipe or a means to declare how we want our application to run, and that's the manifest. And manifest really is a game changer. And in my career, it's the first time I've ever seen a way that you have a way to basically declare how your application runs, and it runs that way everywhere. The Kubernetes manifest at times is quite overwhelming. It truly is. But once you get your head around how it works, it is just a natural way to ship, publish your application in a way that is infinitely reproducible. No matter where you run the manifest, it'll pretty much run the same way every single time. If you think about Portainer, our own product, we ship our product as a Kubernetes manifest. Now, I don't know how all you guys have your applications, or sorry, your kube clusters configured, and it doesn't actually matter. You take our manifest, you run or you apply or deploy our manifest, and Portainer will run for you in seconds, and it will run in a very predictable way. It'll deploy the same way. And we do that because we can simply use things like default storage classes and other things where we simply say inherit what's default in the cluster and run with persistence, with a load balancer, with an ingress. We inherit that. And that's one of the big benefits. So you've embraced the awesomeness of the Kubernetes manifest. Now we want to build on it. So with the same manifest, you can take your application and you can move it from one cloud to another, or one cluster to another. You can scale that. You can actually scale it horizontally or vertically. You can actually move things around. You can say, I want to take this application and I want to move it from cluster 1 to cluster 2, or I want to run it in cluster 1 and cluster 2. Now I want to add cluster 3. These can be different geos, around the world. And it really does open up some amazing opportunities. If you think about how hard it was in a virtual machine world to have full active data centers, dynamic data centers, it was an absolute nightmare. And Kubernetes has really unlocked that. So now you've got the opportunity to spin up clusters anywhere in the world. You can dynamically spin up your application. So you can say, right, I want an application running in the US during US business hours, but I want to shut it down after hours, and I want to bring it up in Asia overnight. You really have this opportunity to dynamically reconfigure. You also have the opportunity to say, I want to use lower cost cloud services for bulk data processing and more expensive cloud providers for core systems of record. So you really have this opportunity to bounce things around. So the edge is an often overused term, and for the purpose of this talk, we're going to define edge as network edge. And when we say network edge, what we're talking about here is putting applications closer to users. And we do this to try and reduce network latency, reduce bandwidth. But the whole thing there is to say, how do I get an application close to my user so they get a snappy, responsive application experience, and I pay less for bandwidth between my user and the back-end system. And edge is all around getting applications out there that aid in things like ingesting, so sorting and filtering. If you think about logs, why send thousands and thousands of logs from an edge location back to the data center when 99% of those logs are useless. So you filter them at the edge, you look for key metrics, and you send back only the signals that matter. Everyone is familiar with a CDN. A CDN is just a network edge technology. It's about putting your application right out there so users get a really snappy response. Think about Spotify and YouTube. Yeah, they're all the same. But equally, latency. Latency plays a really important metric. You know, I'm from New Zealand, and when I'm over here, my internet banking application is completely unusable because it is trying to do API requests, thousands of them, to a back-end server in New Zealand. That latency just breaks the application. So by being able to have API endpoints closer to your users, you get a much faster application experience. One of the often misunderstood opportunities with Edge is the separation of data and control. Now, you can actually say, I want to have some data or an application running out at the edge that's ingesting data from a user and sending it left while control goes right. So you can say, I want this data replicating data or replicating database records to an upstream system or record, but I want the control and communications for this to come from my application vendor. So you've got some control commands this and data this way. So Kubernetes was born from day one predominantly for stateless services. And the Data on Kubernetes working group have done a really good job helping to transition this to more stateful services, but predominantly Kubernetes was around stateless. And edge applications are also predominantly stateless. They're designed for ingesting and churning and buffering and caching. They're not designed really to hold data. So Kubernetes, a stateless orchestrator, edge, stateless workloads, really are a perfect match. So it just makes sense. However, there's challenges. So Kubernetes is a standardized API. There's a whole reason why you get the certified Kubernetes. It's a standardized API. You know if you're using a certified Kubernetes distro, it 100% is compliant with the Kubernetes API. The problem is a lot of CAS providers are not. They want to add value, in speech marks, they want to add value to the native Kubernetes API, but the problem is a lot of that added value locks you into their system. So you need to be really careful with things like authentication with load balancing, layer 7 load balancing, registry authentication. These things, once you start to use them from the provider, may actually lock you into that particular provider. Now, the ones in the middle here, the standard deviations there, Civo, Lino, DigitalOcean, they basically just give the raw Kubernetes. They don't attempt to touch it. It's just the raw environment, and that is the most compliant. To this side, right-hand side, the Azure and Google, they are also very raw environments, add some value add, but are still quite compliant. And to the left-hand side here, Amazon and OpenShift really are quite radically different, and you have to be quite careful that once you start using those systems, you really are locked into those providers, and it makes it very difficult to have a fully transportable application. So multi-cluster Kubernetes management is quite a bit different from single cluster. If you think about a single cluster, you can go and manually create users, you can create your RBAC roles and role bindings, you can go and deploy applications there manually or use dashboards, whatever you want. It's quite simple. When you get 2, 3, 4, 10 clusters, things start to get a little harder. When you're talking edge, though, you really are talking scale. And you really have to change the way you think about how I manage this. And you have to start thinking, how do I do this all centrally? How do I have users authenticate somewhere centrally and those users automatically get propagated to backend clusters? How do I define RBAC roles somewhere centrally and have those propagate? You can't go installing the OAuth extension on all your clusters and managing RBAC roles. You just can't do that. So really the three key points there, centralized access and access control, monitoring dashboards and centralized deployment, you really can't ignore those. How do you do this at scale? So when you have multiple clusters, how do you provide auth access to your users? How do you log them in? And when they are logged in, how do you define their RBAC roles? You don't want to do that one by one, cluster by cluster. Yeah, there's products like Okta, products like Teleport, Portainer as well, that help you do this, but you really have to think about how do I get my users authenticated. You can't go handing out kubeconfig files like they're candy You really do have to say, I want to have a single API endpoint that every developer or consumer can connect to, and that proxies to a backend. This is how you manage things at scale. And same thing with dashboards. Yeah, everyone thinks automatically, okay, I've got Kubernetes, I'm going to install Prometheus and Grafana, and I've got a monitoring dashboard. Yeah, that's cool, but you don't want to have 47 different dashboards you have to open. You want to try and get a macro or a global view of all your clusters. Now, you can do that with Prometheus and Grafana, but you have to architect it that way. You can't just go and install it in each cluster. You actually have to install the edge, the Grafana, and sorry, the Prometheus edge agent, and send the streams back to a central Prometheus instance. You have to configure things correctly. So you have to think differently. And bulk deployment is actually quite complicated. How do you take an application and say, I want to deploy this application, and I want to do so 50 times, 100 times, 1,000 times in the same way, and I want to update it and keep it updated and maintained? You'd automatically default to GitOps, and that would be right, but that's only really half the answer. You know, how do you get the initial install configured? How do you ensure that all 50, all 100, all 1,000 clusters are running the latest version? How do you ensure that? Chick-fil-A, I've put a little link down there. Chick-fil-A roll out a couple of thousand clusters, and they started using GitOps and found out very early on that you can't just deploy GitOps and pray that it's going to update. You actually have to have some centralized dashboard to see the current status of all of these deployments. Are they running? Have they been updated? What version are they running? So I strongly recommend reading it. There's just an extract here, but basically said their GitOps model started really simple, just traditional GitOps, but they learned really, really quickly that you have to have the central control. You know, we found the same thing, and we've added all this capability to Portainer as well. So how do you ensure success? You've got to get tooling. You can't do this without tooling. You can't manage thousands of clusters, hundreds of clusters, to be honest, even dozens of clusters without tooling. You really have to get the central user access, identity management, PIM and PAM, you know, identity management, access management. You've really got to get this. You've got to get the dashboards. You know, one of the hardest things with Kubernetes is learning what you don't know. You know, how do you know what's possible in the cluster? How do you know the commands that are there? How do you know what's running? Your dashboards really do help you see things instantly. You can say, okay, there's a problem there, and you can go and triage it. Unless you have really good alerting set up, a dashboard will never take away, you know, the benefit of being able to say, okay, so there's a problem there, something's not running right. And then centralized deployments. And so Portainer, we have our platform. I don't want to turn this into a vendor pitch, but we have our platform that does a lot of these capabilities. Portainer is a high level abstraction. We try to make things really easy, and we try to be the one tool you need to manage Kubernetes. 1 cluster, 10 clusters, 1,000 clusters, or multiple thousands of clusters. So full Kubernetes API proxy, multi-cluster management, centralized identity management, and dashboards, monitoring, everything you need to basically go live with Kubernetes in production at scale. So, Adolfo.
My turn.
Your turn.
Right then.
Plenty of time to do a demo.
Thank you. Right then. Thank you, Neil, for that.
You remember that, or you have both hands?
Let's see about that. Thank you. Well, so the demo is, as Neil mentioned, really based on having Kubernetes on the edge, right? And the concept of edge is not necessarily devices. It's just the concept of being distributed around a specific geography. So we set up Portainer in a way where, in this demonstration, we're using the full capability of the Civo cloud. We set up 3 Kubernetes clusters in the 3 sites, almost 4 that I saw, but I suppose that's a spoiler. And the idea is to show in the architecture the growth, how you can quickly grow your Kubernetes on the edge using the concept of a centralized console and repeatability, right? So I'm not going to really go through this too much. It's just you guys can download it later and check it out. But I think the visual talks better than words, right? So the idea is to have an architecture of a live streaming platform, right, based on our TMP. So we're going to have I have a little cell phone here acting as a little endpoint that's going to project to you guys. And starting with an ingest server that's going to distribute equally the stream to all 3 sites. It could have been the 4th, but I didn't have much time for the 4th one. And finally, we're going to have an app stack that's going to show the 3 streams on the 3 Kubernetes clusters, each one running on a different site, right? New York, London, and Frankfurt. Right then, so I'm going to start with SSO. So I'm going to keep going back and forth. I'm going to log out of Portainer here. I'm not sharing this one. How do we share this one? Do we have to, do I have to like leave, how's that? Oh, okay, right. So where do I grab this one to? There you go, lovely. Thank you, Neil. Right, so let me log into my Portainer instance. I managed to get very interesting, I might be, I registered a domain.
This is going to be bad for his neck.
Yeah, Portainer Edge LOL. It was cheap, less than $1. So why not? Right then. So yes, first thing, as Neil has mentioned, we really have to have control of who's accessing what. Right? So SSO or PIM/PAM is very important. Portainer supports that. I'm using an open source tool called Keycloak for those who are not familiar with it, and without a face, so I'm going to have to put my code here. Just a second until it refreshes. So the first very important key component of having access to a centralized system is being able to have control over who accesses these systems, right? And here in this Portainer instance, what I have is a mix of, yeah, I think that's better, right? Data center and edge nodes, right? So let me group this by the groups I've created. So here we have the main Portainer server. This is what you're seeing now, running on Civo, New York, if I'm not mistaken. I have a bare metal machine running in Helsinki, of all places, and an AWS data center running in Ohio, and I have the 3 edge nodes running on the Civo cloud, right? One in each of the sites. So what I'm going to do, going back to the presentation, is start by, as you see, the SSO, and bringing the ingest server up. Right? This is where we're going to start sending the stream and the information to the platform. So the ingest server is going to be running in Helsinki, and the method that I adopted in this case was GitOps. Right? Why not? It's one single server. I have control. I'm thinking of only one instance, although if I needed to grow, I might have thought of another method that I'll show soon. But I have more control over that, so I'll just use GitOps. Basically, I'm going to connect Portainer to my Git environment here that I have. Let's see, with my ingest server. So basically what we do is, what I like to say, I connect Portainer. I'll get the ingest name class. Ingest server. Are you good, Neil? Okay. And I connect it to this. Right away, Portainer tells me you need authentication, right? So again, control. You have to make sure you have all the tools to be able to control your deployment. So we have a little feature here where we can cache access to this feature, this environment. And here I can just pull the file. Yes, there you go. I'll activate a webhook here. And I'm going to force redeployment because the package I'm using is a, no, sorry, I'm not going to force redeploy. Sorry, that was something else. So here what I'm basically doing is I'm telling Portainer, talk to this repository, pull the code, which I'll show later, and deploy this onto the server, or better said, to this cluster. That's the first stage of the process, which should show up here very soon. Let's see. There you go. So this is basically my ingest server that's going to bring all the connections and spread that to the other edge devices, or edge clusters, better said. Right then, what's next? Let's bring up one edge environment. Let's bring up Frankfurt. So it's back to Portainer. Now, this is slightly different, and this is what we think of better control over the way you deploy and repeatedly ingest your manifest onto your clusters. You want to have repeatability, you want to have control, you want to make sure it's the same, because you don't want to have surprises, right? So it's slightly different from GitOps. So what we do, we create in Portainer what we call an edge group that's going to concentrate all my edge clusters, all my edge Kubernetes clusters, right? The logic behind it is that via tags, and I have a predefined tag called RTMP, I'm going to group each and every cluster that has this tag here in this edge group. So I've created the group, and now I'm going to connect a stack to the group. Basically, what's going to happen is every time I tag an environment with this RTMP tag, Portainer is going to understand that it has to deploy this manifest onto that device, or devices that are connected to Portainer under that group. So let me add the stack. Again, let me use RTMP edge. I'm going to use, sorry, not ramp. As you see, I'm connecting the stack, which is the manifest I'm going to load onto Portainer, to this group. It'll get easier and clearer very soon. And again, I'm going to use GitOps once more. I'm going to go here. But now I'm going to use another manifest. And this is it. To tell Portainer where to get that manifest from. Again, I need authentication. It's cached. And in this case, it's RTMP. There you go, edge. And here, I'm telling Portainer to use credentials because I'm using a private repository of my containers, which is also called git edge LOL. Right, I'm deploying the stack. So basically what I have is a flow where I have a group and a stack, they're linked, but there's nothing happening here. I need to activate one of the edge Kubernetes clusters. And the way I'm going to do it is I'm just going to go here, start with Frankfurt, and tag it with RTMP. So what Portainer is going to do now is going to realize that I have a device in this group, and it's going to send that stack to that device. It went quite quick because it's a small little container. So each and every environment that I tag with RTMP is going to fall into this group, get the stack, and get deployed. Yep, got it. Right, let's see. Now here comes the magic.
So where Neil gets very nervous.
The network is quite slow. It's a bit laggy.
Broadcasting. Yes, please.
Right, so let's back to the flow. Next thing I'm going to do is really going to show this stream happening by deploying the app stack. So I'm going to go back to Portainer, home, and I have the app stack. And why do I have it in a bigger data center, as Neil had mentioned in the concept of having locations where you really want to concentrate the big bulk of data? Because all these endpoints are doing, they're sending the RTMP streams to this bigger data center where I can process that, transcode it, etc. So here, what I'm going to do is I'm going to use another method of repeatability, which is basically deploying the manifest using a custom template I have here. So I have that already in the Portainer database set to be deployed wherever I want, how many clusters that I have in my being managed by Portainer. Let's see if all goes well. Very soon it should show up here. Okay, and there we go. Right.
Last trick. It is laggy.
So it might take some minutes until it refreshes. Oh, there you go. That was quite fast. But as things grow, sorry, the autofocus is not very good. But you want to grow, right? You need to have repeatability. You need to deploy this in London. You need to deploy this in New York. For the sake of time, I'm just going to rush it a bit and deploy this straight into the other three edge clusters. How? very easily. I'll just go to Portainer, my environments, and say, London, you're up. Update the environment. New York, you're up. Now what Portainer is going to do is ensure that these, and it's going to 2, it's acknowledging on the 3rd cluster, finally it's up. So if I refresh this, soon enough, all 3 sites should be up very soon. I might need to redeploy my ingest, just a minute. How much time do we have? 2 minutes, right. Maybe it'll update in 2 minutes. Right.
The point you see here is it's really easy to just dynamically add machines. So what we're doing here by adding tags is manual. Everything in Portainer is API driven as well, so you can completely automate this. So it's really easy to add brand new clusters. Once you add them into Portainer's management, you tag them, and then they say, hang on a second, now I've got to tag all these stacks should be running on me, I've got to run them. So it's very, very simple to control centrally. It's a brand new environment, you've just onboarded, have nothing running in the Portainer agent.
Maybe I'll have a minute to redeploy this. Let's see. Ingest. Oops, sorry. Repository, Kubernetes, authentication. Little glitch, but it'll be back. As you know, if a demo doesn't go wrong at some point, it's not a demo, right? All right. Because I want to make sure all 3 sites are up. What's the name? It's ingest. Let me just copy it here.
Portainer's been load sized up to about 15,000 clusters, and we're scaling that. Oh, we're scaling that beyond as well. We have customers who've got upwards of 50,000 environments. We have a customer who needs us to expand this up to 125,000 clusters by the end of this year. So Portainer is going through a massive scaling exercise to support that. So from the whole thing, from one central location, you can manage hundreds of thousands of devices. At the moment, about 15,000 clusters, but scaling pretty quickly. We just signed up for a 50,000 cluster test environment to start doing the scaling testing. So imagine how much that costs. In the cloud, I might add.
Come on.
And you see here the whole thing, other thing you can do here, it makes it really simple to deploy applications. You kind of choose your own destiny. If you want to deploy with no code, you can. If you want to deploy with GitOps, you can. But everything is happening within the Portainer system, so you don't need to break out and use multiple other tools.
Let's see if my ingest server is already up.
Is that thing still going?
Yeah. Right. Well, sorry, little glitch.
Because I disconnected the server, so I'll have to restart the stream.
10 more seconds and we're done. In the meantime, you can tell some jokes.
No, I'm not telling jokes. I'm not funny.
There you go. 4 connections, and we should see all 3 screens coming up. So now we have New York, London, and Frankfurt.
There we go. Thank you.
The final architecture is, again, here, just to conclude. Yeah, there it is.
So we have a booth. If you want to see more, come and have a chat to us. We can show you more about Portainer, more than just the edge stuff as well. So.
Can you go back to this screen?
This one? Yeah, which one?
I was wondering if just the lag between the different environments.
Oh yeah, interesting, right? Because I did some tests yesterday, and suddenly Frankfurt was faster than New York. And I realized it's not about really distance. Sometimes it's about capacity, right? So at certain times of the day, New York is busier than London. So lag on London would be shorter and smaller than the one in Frankfurt or New York. I mean, it really depends on the time of the day and capacity that is, or traffic that's being sent to that given space, venue. So it's not, you would think, oh, New York is always going to be faster. Not necessarily.
So like, does this have any tooling around that? Like,
Oh, no, not in this case. No, I mean, this was a very simple demonstration. Obviously,
Okay.
there's elements that I left out just to make it
Okay.
faster to deploy. But yeah, definitely you would have to have some sort of load balancing or geo balancing to ensure you're sending the stream to the right server, et cetera, et cetera.
Yeah, one of our ISV partners is a company called LiveSwitch. They actually do this as their full-time software stack. And we were planning to use theirs today to demonstrate it, but we couldn't get it done in the time frame of the demo, so we had to do a really cut-down version.
All right then, thank you. We're ready for questions.
Thank you very much.